this will be my first live event with my face on it. I don't know if I should be doing this. Okay, the people at home are like, what the heck, his face is on it.
Wait, do your best face.
Sorry, my...
It's so weird because I'm looking forward, but I can see you.
Oh,
good one.
So you'll just have to tell me if this looks dumb in the video. I mean, we can always do this, but you know.
Yes.
No, who wants that? Okay. All right. So we're on question 17, the airplane. Now, I have a very important point that all of you and the fans at home should be watching, okay, and listening to. You are taking a multiple choice final exam. Now, I know you already know that information, but when you look at this airplane question, you have to find the ground speed and the bearing, right? What if, are you listening? Didn't feel like it. What if all the bearings were the same? So if you looked at all four answers, A, B, C, and D, they had magnitude, bearing, magnitude, bearing, magnitude, bearing, but all the bearings were exactly the same. So in other words, you would be wasting your time to find the bearing. Okay? Now, so what I'm trying to get at is, yes, I'm going to go through all these questions with you, but when you're doing the real final exam, please analyze the answers. I mean, you guys know how to write the equation of a parabola in standard form. If I give you the focus, do you see the focus inside the parabola formula? Or do you see the vertex? Do you see the focus or the vertex?
The vertex.
You see the vertex, right? So if I give you the focus, and answer choice D uses the focus, wouldn't that be a bad answer? I guess what I'm getting at is analyze the answers too. Maybe when after you get done reading the question, analyze the answers first. Because that might help you get to the answer faster. Okay? There's only 50 questions. But my guess is time is going to be an issue for you guys. All right? So I'm trying to see faster ways of doing things. Okay? I did look at the formula sheet. It does not have the Pythagorean identity on it. So you will have to know the Pythagorean identity. Sine squared x plus cosine squared x equals 1. Right? Kind of like the Pythagorean theorem. And I would recommend knowing his cousins. Okay? I don't know. They're not on the formula sheet. I mean, I can ask if we can. I mean, the team has to decide. I mean, for instance, I went and said, hey, we need a unit circle. There's no way I'm giving this final exam without a blank unit circle, and they agreed. So. No, I just think they overlooked it, and you know, I was going through the test, and I'm like, if we want to speed this thing up so that they can get through everything, they need to be handed a blank unit circle just to make it easier for them. So, and they agreed. They agreed with me on that one. All right, pause for stationing. Okay, so, hey man, we just kind of been chilling here a little bit. All right, so the airplane flies on a compass heading of 390. You guys got to get used to the idea of the bearing scale, and you can't use sine and cosine and tangent unless you convert it to the unit circle scale. So if something is heading at a bearing of 90, that would be the equivalent of what on the unit circle? 0, right? So the vector for the airplane would be 340 cosine 0, comma, and I'm going to run out of room here, but 340 sine 0. Now, you and I both know the cosine of 0 is 1, and the sine of 0 is 0. So this is really, what, 340 comma 0? So,
Wait,
yes.
so do you have to change it to unit circle, or can you do 340 cosine 90?
Oh, you have to. Cosine and sine cannot use the bearing scale. They have to use the unit circle scale. The airplanes use the bearing scale, ships, but cosine and sine use the unit circle.
So
Sorry.
then if you were like in between like 0 and 90 or something, then you would still change it to
Yeah. So if we said a bearing of 22 degrees, or let me look at the other one, a bearing of 112. So a bearing of 112 is going to be taking me down into quadrant 4.
So it's really like 2.
Okay, but you can't. So if you're going to what triangle is that? You're down here, and you have a magnitude of 31. You did a bearing of 112. That leaves me with 22 degrees in this corner, doesn't it? Does that make sense? Yes, no?
No. How do you in that corner still? You subtracted from.
So the 22 degrees was this part right here in the green. You went past the 90 by 22 degrees.
How did you find that?
How did I find 22? I just subtracted. Okay. So for the wind, I'm going to have 31 cosine 22, 31 sine 22. Okay, now, are either one of those negative? X or Y? The Y value, because it's going down, so I have to put the negative on it myself. So I'm going to be adding these two vectors together, this one right here and this one right here, using my handy-dandy machine, which should be in degree mode, otherwise I'm going to mess this up. Okay.
So you can't simplify it to the shorter one since there's a
What do you mean simplified to a shorter one?
You can't just put 31, 22.
31 cosine 22 is the X value. You can't just change it to, I don't know what form you're trying to change it into. If you're trying.
I just don't understand how you add them. You just take the first
Okay, so the X gets added to the X, and the Y gets added to the Y. That's how we add any vectors, right? X plus X, Y plus Y. So I got 368.7 and negative 11.6. Now, big question is, can I draw over my face?
try.
Oh, yeah. Look at that, man. Okay. Here, let's see. Let me put a little pie tattoo on my forehead. No, it drags the picture. Drags the picture. I didn't know you could drag the picture. I put myself right in the middle of a problem. Okay.
You are the problem.
I'm the problem. Okay, thanks. So we got 368.7 and negative 11.6. Sorry, running out of room here.
Is that the ground speed?
Nope, that's the component form of the combined vector. How do you find the ground speed of that?
Oh, and the
Magnitude,
magnitude.
right. This is a good old magnitude. Oh, that's a bad looking A. Magnitude. So we got what? Square root 368.7 squared plus 11.6 squared. And then I take the square root of that. Wow, that's weird. I got 368.8. Did you guys get 368.8?
Yep. But I have 68.9.
Oh yeah, 0.9. You're right. Oops. It's not my eraser.
I got 68.9. Well, if you add it to 9,
Okay, so 368.9 is the magnitude, right, when we did our Pythagorean theorem. All right, which is that part. And then, how do we find the angle measurement here? The angle measurement inside the triangle? Inverse tan. Now, folks, you're taking a multiple choice final exam. Is it possible, like for instance, if you know it's inverse tan, are you going to write tangent inverse on there because you want to show your work? Am I grading your work? No, I'm grading the multiple choice answer here. So please make sure that don't waste your time. If you know it's inverse tangent, then just type inverse tangent 11.6 divided by 368.7. 1.8 degrees, right? When I do the inverse tan. 1.8 degrees, right? Tangent inverse.
So the negative doesn't matter, right?
No, the negative doesn't matter.
So the ground is 368 and 0.9, and then
Well, have we found the bearing yet? Whoa, it's not letting me.
We have to add the 1.8.
I forgot about that one.
Okay, so now we got to put that back on the bearing scale. So it's 1.8 degrees past 90. What would that bearing be? Yes, so the true bearing would be 91.8 because you had to come past the 90. What'd you say?
Do you always add it to the
No. You have to look at the scale and you have to realize what, do you see the triangle that I drew here on the right-hand side of the screen? Do you see that I kind of drew it like it was in quadrant 4? It's really important that you know which quadrant you're in.
What do you add it to if you're in the second quadrant?
If I was over here in the second quadrant, I would be adding it to 270. If you were up that way, you'd be adding to 270. If you were down here in quadrant 3, you'd be subtracting from 270. That's why it's important to know which quadrant you're in. The picture is important. And if you think about it, you got a positive x and a negative y. That guarantees you which quadrant you're in. If I had a negative x and a negative y, that would obviously be quadrant 3.
I still can't do it, but why don't you subtract from 270 if you're in the second quadrant? Why do you add?
Okay, good question. And I think I know, because you have to realize that you're moving around this way. The bearing goes from 0 and it goes in a clockwise fashion. So if you're in what we call quadrant 2 for the unit circle, you have gone past the 270 bearing.
So if you're in quadrant 3, you can either subtract from 270 or add to 180.
Well, I would suggest you subtract from 270 because you would be finding a quadrant 3 angle that looks like that. So you would be coming down from 270. It would be wasting my time to figure out the other angle and then add it to 180, although I could do it that way. But we're just trying to not, slow things down. Okay, eliminate the parameter. So what are we going to do with this? Get t by itself? T equals x over 3, okay. Okay. Now, remember it's a multiple choice test. What if there's another way to write that? Is there another way to write that? Y equals 1/3 x plus 7. Just understand that it's multiple choice and you just have to look for the answer that goes with what you know is the truth. Alright, same thing here, so I'm going to square both sides. So t equals x squared. And then I can plug that into the other one. Y equals 2. Oh, I did write t again. I'm trying to eliminate t. Somebody stop me. In the name of love or good math, In the name of math parties. Okay, time for a graphing calculator for question 20. So pull out that calculator. Y equals... Better check my mode. Which mode do I want to be in? Beast mode. Parametric mode. Or beast. Is that how you spell beast? Parametric? Or is that how you spell parametric?
Parametric is a
Okay, so I don't pretend to understand him either. So
You have to spell words with letters, and parametric is not a letter. That's not how you spell it.
so the xt equation would obviously be your 2t, and your yt equation would obviously be your t plus 4. So use your 2t, t plus 4, and sounds like, okay, so what's my t min going to be? If I go to my window, my t min better be this. T min. Not demon. T min. Okay, and my T max better be what? 3. You don't have that set up, we're in trouble. Question 20? The one in large font? Okay. Whoa, that's pretty cool.
Is this what you got?
I got this line that looks like this. Is that what you got?
Wait, is this what you got?
Yeah, but I don't know what's your highest y value. I went from negative 10 to 10 on my x and from negative 10 to 10 on my y. So, and I got something that looked kind of like that. Any other people out there in TV land? Got something different? Yeah, who's actually trying? Are you typing? No. Yeah. These people are gonna make me mad. Not reviewing for the final. Shh, stop moving myself. All right. Determine which will travel farther. Baseball X hit 118 feet per second at an angle of 35 relative to the ground. Or Y. Man, why are we doing it like this? This is different from what we did in class where we worked on, will the baseball... Let's just change the question.
Are we using the formula?
Of course we're getting a formula for this. Okay? So let's see, how can we change this question? All right, so we're going to go with 118 feet per second and an angle of 35 degrees. How high is the wall? You tell me. Pick a number for the wall. How high is the wall? What do you want? A 40-foot wall. Okay, so we got a 40-foot wall. All right, we're modifying the question, folks. And Mr. Schwackett, how far away is the wall from us?
How about we do 50 feet, I guess.
50 feet. Okay, man. Is this a little league diamond? Is this like a T-ball diamond? Okay.
Hey, multiply that a little bit more.
No, that's okay. That's okay.
I like.
Let's go 350. Let's just try 350.
Like
350 feet to the wall. Okay. It was a nice try. It was a nice try. I just thought
We
it.
could make it a little.
If it was. Okay. Hey, we could try that. You know what? Let's just do it. Let's just do it, man.
If the wall was 50 feet, I probably could not even be able to.
All right. Let's just go with 50 feet to the wall. Okay. Man, we're close. We're gonna see if we make it over. Okay. But it is a decently tall wall you threw at me. It's not like a 10-footer or something. We got a 40-foot wall. Okay, that's right. We'll call it the Purple Monster. Well, because I can use the purple here. Okay, so, okay, now, what? Something wrong? Did I say something wrong?
No.
Yeah, I did, didn't I? Yeah, oh man, do I have to edit this?
That's the one Halloween time with the purple monster. The purple.
Okay, all right. If I did, I apologize to all my fans.
Wait, you didn't say anything wrong. I was just
Okay.
making a weird noise.
Okay. I don't know. Did I do something wrong? If I didn't do anything.
No, you did nothing.
Okay, I just want to make sure I'm not.
Just color.
I'm just trying. Yeah, I'm just colorful. Well, in Boston they have in Fenway they've got the green monster. We just have the purple version. Okay. So we've got our angle, we've got our speed.
First, you make an x equals.
Right. First, we want to use the x equals. So we use the 50 feet to the wall, and we want to calculate,
Equals 118 cosine 30.
we would like to calculate how long it's going to take to get there. Now, I'm guessing that if we only have 50 feet, oh, by the way, we need to have an original height.
Oh, 5
So, what did you say?
5 feet.
5 feet? You mean I'm going to swing at this and hit the ball up here at 5 feet off the ground?
Well, not all of us
Yes.
are 4 feet
So you have to
tall,
add
Mr.
5.
Oh, nice comeback. That was a good one. That was a good one. Yes, yes, yes.
All of us are-
Got me back for the Tyrannosaurus Rex comment. Ouch.
Wow.
Whew.
Oh,
Roasted
yeah,
back.
That's a good point.
What's the...
I just got
Okay. Let's go with an original height of 2, not 5.
Why do you laugh at everything?
What? Because it's funny. I'm like...
I'm not trying to be funny.
I know you're not. I know you're not trying to be funny. It's just when you think about it, you know, the physics of it. Well, for instance, these dumb questions, some of them, they don't give you an original height. Are we really hitting a baseball off the ground like a golf ball? I mean, they literally do that, and I'm like, why?
Okay,
Yeah.
so
Okay.
Who comes up with these questions? We just abandon them.
All right, so we've got 50, and we're dividing by
Wait, you didn't add plus 2.
118. Well, we don't have to do that until we get to the y equation. We don't have to do that.
Really? I've always added 2 steps.
Well, we can't. The x equation doesn't involve the height. The x equation only involves that 50 feet that we were given.
I think I've got it wrong my whole life.
what? The initial height.
I knew I forgot something.
Okay,
How can you remember
so
that?
how long did it take for us to get to the wall?
Wait, I'm not done.
Like 0.52 seconds, right? You know, just over half a second before this ball got to the wall. Now, the question is, now we have to figure out how high it is off the ground. So, we're going to figure out, so we got negative 16 times 0.52 squared plus 118 sine of 35 times 0.52 plus 2. All right? So negative 16.52
Oh, I
squared
Does
plus
Was there one?
118
I don't know.
Do you put the 1
sine 35 times 0.52 plus 2. And what do we get?
calculator by mistake?
Yeah, I have it in degree mode. Yep, I'm in degree. I got 32.9.
You got who?
Oh, I didn't. Never mind.
Did you guys get 32.9?
Where do you plug in the second T again? Oh, wait, I did.
Well, your first T is
Oh,
over
no,
here,
I
and the
didn't
second
know.
T
I
is right
didn't know.
there. Okay, so I got 32.9 feet.
Yeah, I got that.
Did we clear the wall?
Yeah.
No, we did not. No. Okay, we missed by how much?
8,
7.1.
7.1. Okay, Mr. Stanley. So if the baseball,
So, I made fun of your selection of 50 feet, but that was actually pretty decent. Now,
Well, because
having a wall 50 feet away from home plate is a little bit ridiculous, but we didn't even make it over that wall. Wow.
I mean,
All right,
because
I
it's
think-
so
I think
high, and
50.
if you're closer to
What
it,
if-
then I feel like it's harder.
I think the wall's at first base.
what if the baseball had a
Yeah.
39.9
Yeah.
feet?
Wow. If you get an inside the park home run on that, that's some seriously bad baseball. Okay, you hit the wall, it took half a second to get there. Can you catch it off the wall? No, probably
If
not.
it's fair, but it's fair.
If it's fair, you can catch it off the wall?
Not like if it bounces off the ball and you catch it, it's fair.
Okay. But it's not, you couldn't like have it ricochet and bounce into your glove and call it an out. Okay, I was like, man, I can't remember the details of this. Yes.
What if you hit the wall at 39.9 feet? The ball would definitely roll over the wall. Like it would.
Oh my goodness, we're going to argue about whether it's going to roll over the wall at 39.9? I don't know about that one. Okay, So we obviously have modified question 21. We didn't do the actual question 21 or 22. We did the one like we did in class, which is more typical. This one that they've done right here, the reason I don't like these two questions here is because they force you to go the opposite direction. Okay? Determine which will travel farther. Well, okay, so what do you plug in for the time? You don't know. So you have to use the y equation first and set it equal to 0. The y equation is a quadratic. Set equal to 0. What's the only way you're going to figure that one out? Quadratic formula, because you're not going to factor it. Right? So you'd have to use the quadratic formula, then you'd have to find a time, then you'd have to plug it into the horizontal one to figure out. So we didn't do that one in class, so we're definitely not having that type of problem on the final. Okay, question 23. Stay with me. Are you staying with me?
Not on the video. I can't say
Get
something
lost.
like that.
Yeah, don't say bad stuff.
Bad stuff.
So,
You tell us this.
don't make me come over there. Okay, so 3-3.
Alright.
All right. Draw a picture. Don't you look down on me. Yeah. He's throwing shade everywhere. Okay. Now, facing that particular place, what is the radius? What's the radius of that? Because polar coordinates, we want the radius and the angle measurement. Oh, don't start doing that.
It's not one.
It's not 1, that's for sure. Using our Pythagorean theorem, we can figure out it is. Oh, come now, you can do this.
You're rushing.
On the Pythagorean theorem? Well, what kind of triangle is this? It's a special one.
Radical 18.
Radical 18. More commonly referred to on the street as 3 radical 2. But you're right, it is radical 18. Can't deny that. Okay? Now, what is the angle? Please list your angle measurement between 0 and 360. What? That's a 45 one, isn't it? We don't even have to really do tangent inverse, right?
It's 45, just like that. Because the 3, 3, and 3.
It's a. Do you remember the basic 45, 45, 90 from geometry?
Oh, yeah.
Okay, now the other way to do it obviously is tangent inverse of 3 over 3. Okay, that's going to give you your 45. What if I was to face the other direction? And if I was facing the other direction, I would be walking backwards to get to that spot. What direction would that be if I was all the way down there? I need to add 180 to the 45, right? So what's 180 plus 45? 225. Now remember, what kind of test are we taking? Don't say final exam, I already know that. Multiple choice. Okay? If you see answers that, let's say they all have, every answer choice, A, B, C, and D, all have 3 radical 2 and negative 3 radical 2 for radius. That's generally probably going to give it away that you probably shouldn't waste your time finding the radius. Don't do this kind of stuff if you know all the answer choices are kind of giving that to you. Go to the part that's the important that distinguishes between the different answers. Use the test to take the test. Have you ever heard that phrase?
Sir?
This would be a good time to do it. All right, now 24. Believe it or not, folks, we got 3 radical 3 and 9. This is a special right triangle. This is a 30, 60, 90 right triangle. Now, you might not have known that right off the top of your head, but you can divide everything by 3 and you could figure that out. Because you've got a 9 here and you got a 3 radical 3 on the bottom edge. If you invert the tangent, what do you get? Yep. So Wait a second. Did I do that right? Yeah, that's less than that. Opposite over adjacent. 3 over radical 3, and then you would rationalize that. Yes. Okay. All right. I'm fine. Sorry. Just having a panic attack. All right. Now, not really. For those of you who've had those, I apologize. I've never really had one of those, so I don't want to minimize your pain. So 60. We found 60 inside there. What's the radius? Okay. 3 radical 3 squared plus 9 squared. 27 plus 81. That doesn't look like 90.
Wait, I got 9 plus 3 radical 3 squared.
3 radical 3 squared is 27. 9 squared is 81. So I got radical 108. Okay. So you're either going to have radical 108 or you're going to have its, let's see, I think 4 goes into that. Does it go into that? 27 times? Oh, yeah. There's 36 goes into that, doesn't it? Yeah, 3 times. So that's 6 radical 2. So you could have, somebody might have 6 radical 260 as an answer. So what would you have for the one that goes on the opposite side, which would go backwards? So negative 6 radical 2 would be the radius there. Going backwards, but what would you, where would you be facing down in quadrant 3? 240, right? Okay, so those would be your 2 polar coordinates for the question 24. Did I go too fast or something?
You got 3 minutes for this one.
I know. Can I what? Find an equivalent equation in rectangular coordinates. Folks, I would multiply both sides by r, making that r squared and 10 r sine theta. Remember, your x squared plus y squared equals what? R squared. And what does x r cosine theta? Sorry, x equals r cosine theta. I gave that one away. What does y equal? R sine theta. So by doing that, what have we simplified this to? X squared plus y squared, we got that on the left side, equals 10y. All right, now, that's not how we would have left the answer on my test, right? We would have brought the 10y over, we would have completed the square. Right? In fact, you probably, if the answer choice is that, I think you could go with that. Okay, but if that answer choice isn't there, then you're probably going to have to bring this over and complete the square. So, what are you going to add in there?
Negative 10
Yeah, so b squared over 4 times a gives me 25. So we're going to add 25 to both sides. So I know for other people you might be using the old cut it in half and square it thing. All right, so what is this? What goes inside of the parentheses when you factor the y's? Y minus 5. So that would be another good. That's what I was expecting when we tested on that. Yes?
Then when do you do the thing where you like divide by 25 and have like the y minus 5 squared over 25?
That would be an ellipse, but in this case it's a circle. Now, when we did that in class, I didn't take off if you divided by 25 at all. Okay, so this one, what would we do? Same thing. Multiply by r on both sides. I don't think that's going to help me.
Oh, you changed the cosine.
What if we distributed that and had 2r cosine theta equals 1? I'll have to think about this while you guys go to lunch.
You do that, Mr. Staley.
All right, so just to finish this one up, I know you guys all left and all, but so I'm going to put this term on the other side, giving me 1 plus 2r cosine theta. And I'm going to square both sides. Let's just do that here with a different color. I'm going to square this side, and we're going to square this side. Okay, now we can do our substitutions. Right here we have x squared plus y squared, okay, on this side. And then on the other side we have 1 plus, I'm hoping that you see right here that that's x. So 1 plus 2x, and then we can put our square on it, okay? We're not going to get any fancier than that. Yeah, I'm not going to FOIL that out and move all these terms around and complete square. That's just a series of ugliness. If you look at the formula sheet, they took the square root of both sides. You don't need to do that. Seems like a little bit of a waste of time to me. Okay, and we will continue with another installation of These Are the Days of Our Final Exam at a different time. Have a great day and keep studying. Make sure you analyze the answers on those final exam questions, because you could really waste your time doing different things. I mean, if you don't need to do the Pythagorean theorem because all the answers have the same magnitude, don't waste it. Just go to the direction or the bearing, or if all the answers have the same vertex, don't find the vertex of a parabola. Go to something else which distinguishes between the answer choices, so you can speed things up.